So guys, I want to check to see that you did 3.6. While I'm checking, I would like someone, some brave soul, to show the work of how to find that tangent line to this curve. Okay, I will pick on people if no one shows us how to do tangents or derivatives or things like that. Yeah. Abby, can you show us just the derivative? It's just remembering the trig.
Some of the, especially some of the long ones, just took me so long to do this twice. There's really some mistake that happened, like some like exponential.
I know, the hard part is writing on the board with your fingers, like, you got straight.
I looked for the answers. So maybe we can do parentheses one plus this one, but I said voice in the parentheses.
This was over one side. And then I'm like the one set. That is one.
Hard to read, so it's up there.
And then just like this. I didn't even find it. So is the okay. It's actually
It's much bigger.
How do you get cosine of 3?
We're supposed to be by the get a magnifying glass.
Minus
How does it
plus 2 1 over 2.
Oh, wait.
You can cosine a lot there. Because it's just like one.
Yeah, over 2.
just your options.
Double.
I'm not sure, I've been looking on the back of this and oh my god,
It's a double still, isn't it?
I don't think so.
What?
If you look at like 21.
It was one of the questions, like, how did I, like, was it hard? Only like, not though, but it was mostly easy, but I don't have to memorize it.
It doesn't, you're right, it does seem maybe weird.
So like, it's like, it's just that
That's what I
Correct.
I don't know, we'll see. All right, guys, let's look at it. First of all, first period was like, went on, assuming the way the graph looked, like, oh, well, it's at x equals 1, and it, no, you gotta actually calculate. So part A, find the tangent to the curve. Okay, we want a line. It gave us the coordinates, so we needed to find the slope. The slope is the derivative. So the derivative of 4 goes away. Derivative of cotangent is negative cosecant x squared. The derivative of negative 2 cosecant is positive 2 cosecant cotangent. And the slope there, cosecant is sine upside down, sine is the y value, so cosecant of pi over 2 is positive 1, but that was a negative. So 1 squared, negative 1, and then cosecant of pi over 2 times cotangent of pi over 2, cotangent of pi over 2 is 0 over 1, so it's, the slope is negative 1. So for part A, the answer is y minus the y value equals slope times x minus the x value. Okay? Craziness? Part B is a different beast. Part B says, where is there a horizontal tangent to the curve? Okay? But it's asking where is there a tangent to the curve. That you need to know the slope. So we still needed this derivative. And what does it mean when it's horizontal? What is the slope when it's flat? 0. So when does negative cosecant squared x plus 2 cosecant x cotangent x equals 0? Factoring out negative cosecant x. Is, where is cosecant x 0? And where is that 0? How did I get that there? Because I had cosecants and cotangents, and I have cosines and sines. How did I do that? Cosecant is, Sam?
Well, for 0 equals cosecant, there's no place for 0. And for the other one, you divided all the terms by the sine. So cosecant over sine is just 1, and 2 cotangent over sine is just 2 cosine.
Okay, so I did pre-calc. Cosecant is 1 over sine. 2 cotangent is 2 cosine over sine. They had the common denominator, I put that. So Sam said cosecant's never 0. If you remember the graph of cosecant is sine kind of popped. So sine goes like this, asymptotes. Cosecant is negative 1 and lower, positive 1 and bigger. It's never, ever, ever 0. So he said immediately throw that out. This one, multiply both sides by sine. So when does 1 minus 2 cosine x equals 0? Is where does cosine equal 1/2? And I am only going to write the answer pi over 3. Why only pi over 3? Looking at the problem. Jared?
because the graph is in quadrant 1 mostly, and that's where it is.
Because this coordinate it's between 0 and pi over 2. The one answer I want is that pi over 3. I don't care about any others. Okay, so all of that mess. So it wanted the equation of the horizontal line. Well, I finally found the x value. The x value is pi over 3. Horizontal line is y equals some number. Y equals what number? Go back to the equation and plug in that pi over 3. And across from pi over 3 is root 3. Ooh. Cotangent is adjacent over opposite. Cosecant pi over 3 is sine upside down, so that's 2 over root 3. So it's going to be y equals 1 root 3 minus 4 root 3. 3 over root 3. Do you guys agree that that's root 3? Really? Some of you guys are like, no. Well, that's the square root of 3 times the square root of 3. Reduce. So that's the part B, the horizontal line. Those of you who just looked at the graph and were like, that's 1 and about 2.3. They wanted more precision. Okay. Other questions with chain rule homework or trig homework or the combination of both? Anything else on this page? Yes.
So I just don't really understand what the meaning of the D's are, like D over D of X or D of Y over D of X.
Okay. A derivative is how is stuff changing? How is Y changing over how is X changing? That's just slope. Like, right? And we used to be able to write that delta Y over delta X. Is that familiar? So dy dx, that's our way of saying, what's the instant? Like, with a little radar gun, caught you instant speed going over the speed limit, here's your ticket.
So on the AP classroom homework, a lot of them said D over D of X.
Which, thanks for reminding me. The AP Classroom, there is a student practice problem out there due Wednesday night. This is asking how is that function changing? They might have said it's something specific. How is that thing changing as X moves? Or it might have been how is that thing changing as time changes. They could have, it's just yet another notation to say derivative. Anything on these? 27. But by the way, this is blurry and hard to read. It is double prime, it's not y to the n. So that's asking the double derivative. Ivy, how do I do the first derivative of theta tangent theta? I just want to do product rule. What is the first derivative? So first times the derivative of the second plus the second, which is times the derivative of theta, which is just 1. There's your first derivative. But it asks for second derivative. So Arabella, what is that product now What is the first part of this guy's derivative?
Theta times, wait,
Now the derivative of secant squared, so first left alone, times the derivative of secant squared, which that's a chain rule in itself and its trait, so it's a royal
so
pair.
you can put secant in parentheses and then secant.
Okay,
Theta.
okay, and I'm not gonna do that because I don't have the space.
Okay, two,
So multiply by the power,
and
then lower the power.
then the derivative of secant is secant theta tan theta.
Yes. That is only the first part of product rule. She did first times the derivative of the second. And you can do this a couple of ways. You can do it as secant times secant and work with it that way. Or you can do power rule, multiply by the power, and lower the power. This is secant to the first times the derivative of secant. We get that. Okay. Nick, now the second one, secant squared times the derivative of the first, which is, what's the derivative of theta?
0. 1.
Just 1. And Austin, what's the derivative of tangent?
Is it secant squared?
It is. Go ahead.
Why is the derivative of theta 1 and not 0?
Because it's asking if this was x tangent x, the derivative of x with respect to x is just 1, right? Well, this is the derivative of theta with respect to theta, that's just 1. So part of the problem with this is they changed the variable on you and you guys don't like that. You're like, it's in curly cute cursive letters, I don't know how to do that. Okay, just cleaning this up a little. This ends up being 2 theta secant squared tangent plus 2 secant squared. And thankfully, they didn't ask for the third derivative because that would really stink. Okay. There were lots of questions on this. Issues? Questions, comments, concerns? Matching it to yes.
Could you just solve 23?
Could I? Well, probably. 23. Okay, it's asking for the first derivative. Is that 4 over 3 pi? Is that a variable or is it a constant? What is it? Constant? Okay, so it's just like 2 sine something. So it's just gonna be there. Derivative of sine? Cosine. Leave the inside alone. But now chain rule, times the derivative of the inside, which is 3. Those guys are gonna reduce. That one's now done. 4 over 5 pi, it's a scary looking constant, but that's all it is a constant. Outside of derivative of cosine, negative sign, and leave the inside alone. Eddie, times the derivative of the inside?
0?
Derivative of, oh, yeah, you can't read that, can you? Derivative of 5t.
Oh, 5.
You'd never know it, but when elementary school, they made us learn handwriting and things like, but I wasn't taught this way. Okay, so this is 4 pi cosine 3t, and then minus 4 over pi sine 5t. And that is our first derivative, and that's all they asked for. First period was like, oh, do we need to factor out the 4 over pi? If it helps and reduces something, sure, but if it doesn't do anything, you can leave it. One thing the other class didn't ask about, because I don't think any of them got to that page yet, 57. You have had some exposure to these because I made you do some delta math. But as an example, okay, that I wrote down is gone. They gave you a table with some information. Part A is just, okay, do the derivative. So, Ren, what is the derivative of 5x? 5f of x. So the 5 doesn't do anything, it's still there. And what's the derivative of f of x? F prime of x. Cleo, what about the derivative of g of x? Negative g prime of x. Yeah, doesn't really do much. Okay, that's the derivative, but they wanted us to evaluate it here. Okay. So, Chen, I wanted to evaluate it at 1. So, what is f prime of 1? And Carmen, g prime of 1. So negative 5 thirds plus 8 thirds. Like, it looks scary, but are you guys okay with this style of presentation?
You go B and C.
B and C, maybe. Now it's getting ornery. Well, there's B. And the student that did it backwards than what I prefer. So product rule, first times the derivative of the second. The derivative of the second, multiply by that 3. So multiply by the power, lower the power, g squared of x. And then you gotta do the chain rule. Multiply by the derivative of the stuff inside. And then leave the second one alone and the derivative of the first. And then they just plugged in the numbers. C is kind of like one that was on the last quiz. Bottom times the derivative of the top. So g of x plus 1 in parentheses times the derivative of the top minus the top times the derivative of the bottom. Derivative of the bottom, the 1 goes away, and I have a g prime of x over the bottom squared. So then at 1, g of 1 is negative 4. F prime of 1 f of 1 again is 1 g prime of 1 negative 8 thirds over this squared. So negative 3 times 1, negative 1/3 is positive 1 plus 8 thirds. I feel like I did something wrong because I thought it came out to something nicer than this. That's a 3. 11/3, 11/27 feels wrong. So I probably did arithmetic wrong. Did anyone do this problem? Is it solidly wrong? What I messed up?
X is 1.
F of x, f of 1 is 3. That's why. Thank you. That's better. It's more like the number I was expecting. Okay. Any of the parametrics that we should go over? Yeah,
You go with 27.
27. Mostly, you guys don't like this because it's not X's and Y's, it's R's and betas. So, don't be too stressed about it. So, I see a product and a power, and a trig function and a polynomial. What is the outermost function that we need to do first? The power. Okay. Multiply by the power, lower the power. Okay, derivative of the stuff inside. Matthias, the stuff inside is a product. How do I do the derivative of that product?
You're going to do product rule.
Okay, how do I do product rule?
Derivative, so 2 times.
The product is
Product
theta.
inside. Theta times cosine theta plus sine theta.
Why do you say sine theta and you're done? Because it's times the derivative of the first, which was 1. So it's sine theta with authority. He ended. Is that it? I could put this on top of that, but that's it. Let's see. There's probably another one we should do because everybody asks. Yeah,
I was going to say, could you do 17?
that was the one. Might be 19.
I have a question on this one.
You have a question on this one?
The derivative of, oh, never mind. Wait, never mind.
Good?
Yeah.
Good talk. 17
Yeah.
You said?
Or 19.
or
They're
19?
like the same.
Yeah, okay, well 19's the evil one. We'll do 17 first. If you need to change how things are written to get the problem right, by all means do that. So that little squared on the sign, you can rewrite it as that squared. So Jared, first step to doing this derivative.
Well, if you multiply by the power of the power, so it's 2 sine 3x plus 2.
Okay? First one, first outermost function. Multiply by the power, lower the power. Add me. Now, times the derivative of that stuff, which is,
That would just be cosine 3x plus 2.
okay,
And it's
okay. And don't leave it like that. Multiply the 2 and the 3 together. And those of you who are really good with your trigonometries, yes, there are things you can do. Do you need to? No. Like, Remy would be like, well, that's 2 sine theta cosine theta, so can I write it as sine 6x minus 4 times 3? You can, Remy, and that would be a pain. Because your answer is going to look different from everybody else's. But just know that with the trigonometries, you can get correct answers that look very, very different. And the AP exam, I haven't seen them force you to use trigonometries like that. But you do have to be flexible with how you take your right answer and make it look like theirs. Like one of the big things is log. They can make log look very different. 19, how many functions are in there? 5? 2? Too many. Well, there's the power, and then there's the trig function to the power, the trig function, and the polynomial, I see 4. Colin, what is the outermost operation in this 19?
Did the square or the cube?
Yeah, so how do I do power rule with that?
You just take, put the 3 out, lower the power, and then take the derivative of the inside.
Okay, so that's the first step. Oh, and what's the next step? He said, he did power rule for us, so now you need to do the derivative of that. What's the derivative of 1? Okay, so what's the derivative of cosine squared stuff? Is the cosine the next function, or is the squared the next function, or is the stuff the next function? The squared. So multiply by the power, lower the power. Okay. Next function. Roman, the next function is the cosine. How do I do the derivative of the cosine? Negative sign of stuff. Ethan, the last one. Just the derivative of stuff, which is 7. Okay, and here, there's really nothing much to combine, but don't leave this as an answer. I will take points off on a quiz. Take this 3, this 2, that negative, and that 7, and do the multiply and bring it out front. And again, you could do some trigonometry stuff with it if you were so inclined. Yeah.
So why would you be -2 sine 7x for the derivative of the 2 cosines?
The stuff in green. Let's see.
So like the red.
Right, well, we're doing the derivative of that. Multiply by the power, lower the power. And now the thing that was being raised to the power was just the cosine, the 2 wasn't on it. Good? Ivy? Oh, yeah. Sam? First step to 13?
The first step to 13, you can do the product rule, so take the derivative of, I should get the derivative of sine cube x, which is 3 sine squared x, tan 4x.
Chain rule. So multiply by the power, lower the power, but then you gotta multiply by the derivative of the stuff inside, which was, what's the derivative of sine? And then there's that tan 4x. So that's first, all the stuff in green is the first derivative times the second.
Is 4 secant squared 4x times cube x.
So of course you do it backwards. First times the derivative of the second, plus second times the derivative of the first, and things don't clean up much. Yeah.
Factor out a sine squared.
We can. Does it help anything? I mean, so that's the warning is, is at least they made it a 4x. If they didn't, then the secant and the sine could combine and make a tangent, and then like all kinds of nasty things, but the angles are different. Okay, unless you have other questions, I would say at least log in and look at the AP classroom question. Owen? Chain rule of this. Derivative of tangent stuff is secant squared stuff. But you need to remember to use the derivative of stuff, which was 4x. Derivative of 4x is 4. Yes, Jared?
We have textbook.
No.